to our channel. Today's topic is algebraic identities. We are building up the most basic identity, that is a plus b the whole square. Here we are taking help of this particular grid where this is a units, this is b units. As you can see the rectangle here, it is describing all individual areas where this area is a square because this is a square. This area is going to be b square side into side. This rectangle, which is this shape here, its area is AB. And again, this rectangle is also going to be AB. So individually, we will add up these areas to get the identity a plus b the whole square. So we are adding up a square plus the rectangle R1, which is AB, plus the rectangle R2, which is again AB, and then the area of square with side b, so this becomes b square. So our identity is a square plus 2ab plus b square. With the help of this, so this is very simple. A plus b the whole square, the expansion was supposed to be a square plus 2ab plus b square. We haven't written the coefficients for a square and b square. Here it is 1 and this also is 1. We will go to the next identity, that is a minus b the whole square. So if I consider this as a in terms of a plus b, it should look like a plus negative b the whole square, which if we use the above identity, it would become a square plus 2 times a times negative b plus negative b the whole square, which eventually becomes a square. This is a plus and this is minus. Plus into minus is minus. So this would become a minus 2ab, and the last term, because it's squared, so it becomes plus. So this becomes plus b square. So the most important bit here is that whenever if b is negative and the power of b is even, that term will turn out to be positive number. Here we have positive. The power of b here is 1, which is an odd number. Thus the sign here becomes minus. So that particular principle will be applied all throughout. Now we have understood a plus b the whole square and a minus b the whole square. We will use the combination of these two and we will arrive at a new identity. So if I take the difference of these two identities, a plus b the whole square minus a minus b the whole square. So here in this case we will use these identities here. So we know this is a plus b the whole square can be used from here. So we have this, we'll put a equal to sign here. So we are using a bracket to contain that a plus b the whole square. Then we are moving to a minus b the whole square. We use this identity. Of course we will use a bracket again here because we have a minus sign in the middle. So this is minus here. We will continue the operation. This would become a square plus 2ab plus b square minus a square plus 2ab minus b square. So we know that these could be cancelled, 2ab and 2ab, or rather not 2ab, minus b square and plus b square is eliminated. We have minus a square and plus a square is eliminated. Thus we will be left with a plus b the whole square minus a minus b the whole square eventually is nothing but 4ab. 4ab. We have taken a 2ab here and 2ab here, that becomes 4ab. In a similar manner, if we had a plus 1 over a the whole square, we will use a plus b the whole square identity. This is a square plus 2 times a times 1 over a plus 1 over a the whole square. So naturally this a and this a should be eliminated. So we have eliminated them. Now we are left with a square plus 2 plus 1 over a square. In a similar way, if we work on a minus 1 upon a the whole square, this would become a square minus 2 times a times 1 over a plus 1 over a square, which eventually becomes a square minus 2 plus 1 over a square, since this a square a and this a is eliminated. Now we will use the identities number 4 and 5, and we will build similar to identity number 3. So we will now use a plus 1 over a the whole square minus a minus 1 over a the whole square is a square plus 2 plus 1 over a square in the brackets minus a square minus 2 plus 1 over a square. If we continue this operation, we will get a square plus 2 plus 1 over a square minus a square plus 2 minus 1 over a square. Again, we have the chance of eliminating this with this and minus a square with plus a square. We are now left with a simple 4. So here in this case, the identity that we have built is the difference of the sum of the squares, sum of the whole square, and the difference of the whole square is 4 when a is a and b is 1 over a is just 4. So this is the identity that we have built. So we can box this. In a similar way, the same identity with a and b was produced here. So we have these 6 basic identities which is fallen in place. Now we will continue further with the difference of the square identity. We are now going with the 7th identity, which is a square minus b square. This is termed as a plus b times a minus b. Basically, when you expand these two factors, they will produce this. Just to give you an insight, I would show you the expansion. So this, if I do the expansion for this, we get this is equals to a times a minus b plus b times a minus b. Thus we get a square minus ab plus ab minus b square. The plus ab and minus ab is eliminated. So that leaves us with a square minus b square. Thus the identity that we have built is a square minus b square is a plus b times a minus b. This is the difference of the square identity. Now we can continue this further if we have something of this kind where it is biquadratic in nature. A power 4 minus b power 4. This could be converted into a square the whole square minus b square the whole square, which is a square plus b square times a square minus b square. And we of course know that this could be further factorized. So we'll continue. That is a square plus b square times a plus b times a minus b. So we have got the identity for the quartic differences. We have a power 4 minus b power 4 is a square plus b square times a plus b times a minus b. Now just the way we did a plus b the whole square using the grid, in a similar way we can use one more grid and we could arrive at a plus b plus c the whole square. So we are going to use this grid here. So this, or rather I could use it here so that it is fresh page. So here in this case we are looking at a plus b plus c the whole square. So what we have done here is This is A unit, this is B unit, this is C unit. The similar thing is A, B, C is here. So the whole grid that we have used here is a big square whose side length is A plus B plus C. And if you want to figure out the area, then it would become A plus B plus C the whole square, which is what we have written on the left hand side here. So my identity that will fit in here is individual pieces. This would become a square. This is AB, this is AC, this is AB, this is B square, this is BC, this is AC here, we get a BC here, and we get C square. So we individually add them up. So we have A square plus B square plus C square. So we write them as A square plus B square plus C square plus. Now if you look at AC is here as well. So AC plus AC gives 2AC. AB plus AB is 2AB. We have got BC plus BC is 2BC, and these we have already taken care of. So we will use the 2 common factor out. We will write AB plus BC plus AC. This is R. This is R. A plus B plus C the whole square. Now we will move ahead with our cubic identities. So for us, we'll continue the cubic identities here. So we label this as 9. So we have A plus B the whole power 3. The approach is A cube plus A square plus A power 1 plus A power 0. So the powers of A have decreased up to 0. We will increase the powers of B. So here we have got power of B is B power 0, B power 1, B power 2, and this is B power 3. Now we know there's something called as Pascal's triangle, which is 1 1. This is nothing but A plus B the whole power 1 would remain A plus B. So we are using the coefficients A plus B. We know A plus B the whole square is A square plus 2AB plus B square. We are looking to build A plus B the whole power 3. So here, what are the components that will come here? We have already identified this because of the decreasing power of A and the increasing power of B. But now we are interested in knowing the coefficients. So we'll look at how the coefficients can be built using the Pascal's triangle approach. So here the coefficient is 1. We have the coefficient 1 here. These coefficients are taken by the first term here and the last term here. Now, if you realize here, 1 plus 1 makes 2. That's 2 is the coefficient given to the middle term. So this is 2AB. So we build the coefficients here. Now we're looking at A plus B the whole cube. From here we have already understood that this is the case. If we further simplify this, this will become A power 3 A square B, AB square, and B power 3. So we have already produced the terms, which is like a square, AB and B square. Similar terms are present here, but we now need the coefficients. So we will use the Pascal's triangle here. If we reduce it to this, so this is already known that this will be plus 1. This is also 1 because these are the coefficients here are seen here. Now we'll continue this further, and now we'll see what is the coefficient for A square B. So we know this is 1, this is 2. 1 plus 2 makes 3. That coefficient would be here. 2 plus 1 makes 3. That coefficient will be seen here. So now we will give them the coefficient. This is 3. This is 3. If the middle term is positive, that means B is positive, all these numbers will be positive numbers. These are all positive numbers. Positive, positive, positive. So we have understood the approach for A plus B the whole cube. So we will write here, we will write the 1, 3, 3, 1. There's a plus, plus, plus. So we will write this identity again, and we will write it here. Therefore, we can clearly make out that a plus b the whole cube is a cube plus 3a square b plus 3ab square plus b cube. So this could be rearranged to write it as a cube plus b cube plus 3ab times a plus b. This is a plus b the whole cube. This identity in this form is useful when we've been given the value of a plus b, which can be used here, and we also have the value of ab. So this helps us in obtaining a cube plus b cube. Now since we have understood a plus b the whole cube, the same logic will be used for a minus b the whole cube. A minus b the whole cube. So the 10th identity here is a minus b the whole cube. So this is a cube, and then we have got a 3a square b. This is 3ab square. This is b cube. Now, since b is negative, wherever the power of b is odd, that term will be a negative term. This is power 1. So these two terms should be negative. So we are writing them as negative. This is negative, and this is positive because here b power 2, which is an even number. So square of a negative number becomes positive. Thus it remains positive. Now the same identity could also be written as a minus b the whole cube is a cube minus b cube minus 3ab times a minus b. This has been factorized with minus is taken out, 3ab is common element out, which is leaving a here, plus is negative times negative is positive. So that's the reason this is negative. Negative into negative gives you positive. So that is how this becomes positive. So we have obtained a minus b the whole cube as well. Now if in place of p we had 1 over a, these identities then would look like a plus 1 over a the whole cube could be written as a cube plus 1 over a cube plus 3 times a times 1 over a times a plus 1 over a. So a and a can be eliminated. So this identity would then become a cube plus 1 over a cube plus 3 times a plus 1 over a. This is a plus 1 over a the whole cube. Now the same approach can be used for obtaining a minus 1 over a the whole cube. This is a cube minus 1 over a cube. Since this number has an odd power, so this is negative, minus 3 times a into 1 over a will get cancelled, so we'll be left with a minus 1 over a. This minus sign and this minus sign is just similar to these two signs here, including this one. So we have obtained a plus 1 over a the whole cube. A minus 1 over a the whole cube has been obtained. Now this identity was already shown. We'll go to the next identity, which is the sum of the cubes and the difference of the cubes. So now if we had to expand these two factors, that is a plus b times a square minus ab plus b square, if you expand this, we will get a times a square minus ab plus b square plus b times a square minus ab plus b square. So we are left with a cube minus a square b plus ab square plus a square b minus ab square plus b cube. So this signs here, ab square with a negative sign, ab square with a positive sign is eliminated. A square b positive and a square b negative is eliminated. We are left with a cube plus b cube. In other words, the identity that would be applied here is a cube plus b cube. That is the sum of the cubes would be the whole thing here, which is what we started with. So this forms our identity. This is the sum of the cubes identity. So we've built this identity here. We have built this one as well here. We will continue further, and we will now just to understand how we can remember this is, if we were to look at this, it is the sum of the cubes identity. The sign here is positive, so this same sign is given to the first bracket. Here we can say this is same sign. Opposite of, if it is plus in the first bracket, the second term of the second bracket contains opposite sign. Opposite sign. And the last term, since it is a square term, it will always be positive. Always positive. In a similar way, if we were to follow a cube minus b cube, that would be a minus b times a square plus ab plus b square. So if you look at this, the same sign is here. Opposite of negative is positive to the middle term here, and the last term is always positive. So same opposite sign and always positive. So we built this identity as well. Now we will use factorization approach to build one more identity, and we will see how exactly this can help us. So the identity that we're looking at is 15th identity. If we were given x power 4 plus x square plus 1 to be factorized, so we will use middle term. If middle term is 2 times root of first term into root of last term, then it is a perfect square. So here we will say 2 times root of x power 4 multiplied by root of 1, which is 2 times x square into 1, which is 2x square. So here we needed to have a 2, but we don't have 2. So we will try to get the 2. So we can do a rearrangement or some new combination we can produce. So here we will say x power 4 as it is plus 1 as it is. Our need for the middle term is 2x square. So we are writing this as plus 2x square. But here we only had 1x square. So we are forcing one more x square. We will nullify that by saying minus x square. So now this particular group of 3 terms, it has become perfect square. We will write this as x square plus 1 the whole square minus x square. Now this is the difference of the square identity, where this is a square minus b square, which eventually should become a plus b times a minus b. So we will now continue. This is equals to x square plus 1 plus x in the first bracket. The second bracket is x square plus 1 minus x. Therefore, x power 4 plus x square plus 1 in factor form is x square plus x plus 1 times x square minus x plus 1. If in place of x we had used a variable k, then nothing much will change. Rather, it will look like we will use a k here. Use a k here. So if we had k power 4 plus k square plus 1, this would become k square plus k plus 1, k square minus k plus 1. This is the identity that we have produced here. Now, one more identity that can be useful is sum of the cubes of three numbers, where the sum of the number is 0 is given as 0. So here we've been told the 16th identity. Here we've been told if a plus b plus c is 0, then a cube plus b cube plus c cube would be a question mark for us. We are required to figure this out. So we know a plus b plus c was 0. Using this, we will produce a cube plus b cube plus c cube. So since this is given, therefore if we rearrange, it will become a plus b plus c is transposed, it becomes a minus c. Now we are cubing both sides. So cubing both sides. So naturally we are going to be cubing this, the two right and two sides here. So we will have the whole cube added here, the whole cube added here. On the left we know is a cube plus 3, or rather we could use a cube plus b cube plus 3ab times a plus b is minus c cube. But we knew a plus b could be taken as a minus c. So therefore a cube plus b cube plus c cube plus 3ab times negative c is 0. The c cube has been transposed to the left. Therefore a cube plus b cube plus c cube would become 3abc. The negative 3abc is transposed to the right, it becomes positive. So this is also the identity which helps us in solving a cube plus b cube plus c cube, where we know that the sum of the cubes, rather the sum of the number, is 0. A plus b plus c is 0. In that case, this approach simplifies to just 3abc. That is all with